Hi everyone. So this is exercise 1.2 from your jacplus methods textbook, year 12, and we're looking at linear functions. So the first example is not really very linear, as you can see, but it's talking to us about functions, so it's a good one. Here is a graph showing y equals x squared, and as you can see, it's got a restriction. So the first thing they're asking us to do is to explain why the graph is a function and state the type of correspondence. So when we do a function, or when we test for a function, you might remember we use a vertical line test. And the way I remember whether it's a vertical or horizontal line is that parabolas are called quadratic functions, so they're going to be functions. So if you go with a vertical line, you can see it does cut it once. Whereas if you do a horizontal line, you can see it does not cut it once. So the vertical line test is for testing whether you've got a function or not. And in this case, yes, we do have a function. So while we're at it, we may as well see if it's a one-to-one function. And we can see, well, no, it's not a one-to-one function because it cuts twice. So if it's not a one-to-one function, that leads us to saying, well, what sort of correspondence does it have? So the way I like to do this is just to choose a random value. So I'm going to just choose a random x value here. Just pretend that's a 1. And if I go up and there's a point there, and then if I go across, well, then I have some corresponding y value. And well, I'm going to say, well, let's make that 1, which, well, it would be anyway. So on that y value of 1, you can see that there is another y value, or another x value that gives that same y value. So if we were to go down here, it would be a 1 as well. So if I was to write this out, I could say there are 2 x values giving rise to 1 y value, and I'll put the little 2 dots there, 1 y value. And well, what we can say for 2 x values, we can say that's many, and then there's just 1 y value. So we always talk about x first and then y, and that's how we work it out. So if it was that we had 1 x value giving us many y values, or more than 1 y value, then it would be a one-to-many function. So this one is a many-to-one function, and yes, it's a function. So that's part A. Now, state the domain and range. So this is not too bad and is very similar to what we did in year 11. So the domain is our allowable x values. So if we look at the graph, and I'm just going to rub out these things so I have a little bit more room to look at the graph. So if I look at the graph, I can see that the lowest x value I'm allowed to have is a -2. And actually, I'm not allowed to have -2. I can go down to -2 but not include it. So that's why I've got a soft bracket there. That corresponds to this open circle, of course. The soft bracket, just be careful of that. That's a place where a lot of people make a silly mistake. And then here, well, my x value here would be 3. So it's from -2 to 3. So that's my domain. And then, of course, the range. Well, the range is my y values that I'm allowed to have. So the y values I'm allowed to have, if I look at my graph, well, it starts at 0 and it includes that. That's the turning point. So from 0 up to 9. And they're both inclusive. Don't be fooled. It's not 4 to 9. So people might think it's 4 to 9 because the lowest x value is -2 and that corresponding y value is 4. No. That is not how it works. You've got to look at where the graph is going to, and the turning point is included there. So that's part B. Express the given parabola using function notation. Okay, so let's do that. So this is the like the formula for writing in function notation. We put the name of the function, we put 2 little dots, we put the domain, which maps into the real number field, where the name of x equals the rule. So I'm just going to like color code that. So the name, let's have the domain, and this, the name of x, and lastly the rule. So you'll notice I haven't highlighted some of the parts of that because they're always the same. So now if I want to now do that, so let's see, the name of my function, I'm going to call it f. That's a pretty standard name of a function. You call it g, q, whatever you like. The 2 dots. The domain we know is neg2 to 3. And then this thing stays the same, maps into real number field. This is not the range. So you're not going, it's not, no, that's not what we do there. We always, write the arrow and r, maps into real number field, and the name of the function is f of x equals, and the rule is x squared. Now if you look, the rule, there it is. The name, well, there's that. Here's the name again, and then lastly the domain. So this is, I guess, a little formula for how to write it into function notation. And look, you may put that into your reference book, but people do, but there would really be no need, because by the time you get to your exam or even your SACs, you would have done so many of those function notations that it will be second nature. You don't need to write that down, really. You'll have enough practice. Okay, so we've done that. Calculate the value of y when x equals negative root 2. Okay, so if x equals negative root 2, be careful, that's not root neg 2, so don't do that. And that's anyway, we can't root a negative for methods. So if x is negative 2, I'm going to do f of negative root 2. And what that does mean is negative 1 times root 2. So that's going to be negative 1 times root 2 squared. And that equals negative 1 squared is 1. I might just write each part out. And then we're timesing that by root 2 squared. So that gives me 1 times 2 equals 2. So f of negative root 2 equals 2. So you don't need to write all that working out there. I just wanted to point out to you what that negative out the front was doing. Now look, let's just have a quick look at CAS, what we would do. And look, I've taken photos of this. I will work out how to do it on my screen, and I'll do that soon. But for now, I thought this is quite good. So what you can see, a little blurry, a bit hard to take photos of the CAS screen. What you can see here is I'm in graphs and tables here, so from your menu, of course, and I've written my function of x squared, and then what I've done here, and what you really want to get used to doing, is giving it a restriction, if there is a restriction. So this stick here, as hopefully you know from year 11, we're in math 3, and there's the stick, and then I'm writing from negative 2 to 3, and I'm getting those inequality signs also in math 3. There it is. But you'll notice that I have done on both of them this. I have not used this one here. And if we look at our graph, well, we'd say, well, we do need that because negative 2 we're not including. But I've done that on purpose because if you do not use this one, then you can't find that point. If you try and find it, you won't be able to find a corresponding y value. CAS will tell you not found. So it's more handy if you can find it. So once I tick the box and press this thing here, that little graph shape thing, then it's going to draw it for me. It draws it with the restriction. And what I've drawn is that it has solid dots here and there. And CAS won't show that, but it means, as I said, that I'm able to calculate this value. If I have an open circle here, in other words, if I had used this button as the question shows, then I would not be able to locate that. So look, to locate it, we go analysis. So here is analysis, gsolve, I didn't show, and then xcal, ycal, and we want to calculate the y value, so I'm selecting ycal, comes up with this little box, and I'm saying my x value is negative 2. So when I press OK, it's going to tell me that this point is negative 2, 4, and you might not be able to see that so well. Oh, well, you can actually see it down there anyway. But the point is that if I hadn't had this sign, if I would have had this instead, it would give me a not found. and it's not found because it doesn't exist on the graph. There is no y value when x is -2. But if we want to draw the graph, we want to show that. So it is more handy to put that in. Okay, you'll notice I didn't define that function. I'm not using it for much, so and it's a very easy one to write, but often it is handy to define your function. Okay, so that's worked example 1. Let's move on. I won't actually go through these. I'll just point out that, you know, we have this rule for perpendicular lines where the two gradients multiply to be -1, and that's great and true, of course, but most people, I think, I've seen, just like to flip it. So if you have the gradient of 2/3 on one line, the perpendicular gradient you flip and you make it the opposite sign. So we're positive here, it turns to negative. If we had a whole number, well, then we'd put that over 1, we would flip it, and we would make it negative. If it was negative to begin with, we would flip it and make it positive. So this is our rule for finding the perpendicular gradient, and you can use the m1, m2 equals -1, or you can just use that rule that I've just done there. Either way, let's see how that works. So here is a line here, and they're asking us to sketch it, and they're asking us to calculate the gradient. So look, there's a number of ways you could do it. I'm just going to, the sketching by hand, you definitely would use y and x intercepts because it's not in y equals mx plus c form. So 2x plus 3y equals 12, x intercept y equals 0, so that means I'm just going to get 2x plus 0, so I won't write that in, equals 12, x equals 6, and y intercept x equals 0, that's just going to give me 3y equals 12. So y equals, what am I doing? No, definitely not that. 4. 12 divided by 3 is certainly not 6. 12 divided by 3 is 4. So to sketch that, obviously, we can just, you know, put the y value 0, 4, and put the x value 6, 0. Be careful with your coordinates. Don't put the zeros in the wrong spots. Obviously, they're, you know, 0 for y when it's an x-intercept and 0 for x when it's a y-intercept, but it's just a common silly mistake. There's our line, and well, now we can just find the gradient. So you could do rise over run if you wanted. I can start from here. To get down to here, I'm going down by 4. That's not a very good pen. I'll change over. So I'm going 1, 2, 3, 4, so that's -4. And run is going to be, I'm going to cross 6, 1, 2, 3, 4, 5, 6. So it would be -2/3. Alternatively, if we don't have the graph, well, we've got 2 points, and probably more useful actually is to do m equals y2 minus y1 over x2 minus x1. So I would label them x1, y1, x2, y2, and look, under usual circumstances, you'd put the 2's on the more complicated thing, but in this, neither is really more complicated than the other. So 0 minus 4 over 6 minus 0, -4 over 6, -2/3. So that's our gradient. Just to point out that if you are using CAS there, well, we could do that really quite easily. I just went in main and I used my solve function. We all know the solve function by now. It's in Math 1. And I stated the, the equation there, and I put comma y because I want y as my subject. And then I get the line gradient. You can read it right off, the m value from mx plus c, and then you could sketch it with the y-intercept and gradient method if you wanted. Okay, moving on. I think we've got 2 more. Okay, find the equation in the form ax plus by plus c equals 0 for these lines. All right, now before I do this, I am guessing that the book is going to use the equation of the line y minus y1 equals mx minus x1. And look, you can use that. I don't like that. I just prefer to use y equals mx plus c. neither is better or worse. It's just that I like to say to people there is one rule to find the equation of the line, and that way you remember one thing. If we've got 10 rules to do the same thing, then it's harder to remember what to do. By all means though, if you prefer the one I just wrote there, which I'm guessing the book will use, then use that. Anyway, it passes through this point, 2, 3, and it's parallel to this line. So this line is y equals 3x minus 5. So our gradient is 3. And parallel is the same gradient. So far we've got y equals 3x plus c. So, well, then we just do the usual, which you probably did since, I think, year 8. Do this. We sub in the point and we say, well, 3 equals 3 times 2 plus c. That's 3 equals 6 plus c. And, well, neg 3 equals c. So what do we get? Y equals 3x minus 3. And just watch out, because they give us a specific form and they're saying ax plus by plus c. So I'm just going to take this over the other side, so neg 3x and plus 3. So it's negative 3x plus y plus 3 equals 0, because that's the form they want. And look, you would never do that unless it specifically asks, which it does specifically ask in this case. That's an absolute waste of time otherwise. Let's do it for the next one. This one is perpendicular. So again, we need to find the gradient of the original line. So I'll just quickly rearrange that. There would be no use rearranging this on CAS. It just would be a waste of time, because I mean, you can so quickly get your y equals mx plus c. By the time you press the buttons, you would have done it by hand. So this gradient, what's going on? M equals neg 2 over 1. So for the perpendicular, we're going to flip it and we're going to put the opposite sign. So our equation is y equals half x plus c. Again, you could have done m1, m2 equals neg 1, and then you could have subbed in the neg 2 for one of those m's and solved. You'll get the same thing, whichever way you like best. So let's sub in the point, which is neg 1, 6. Neg 1, 6. So 6 equals, half times neg 1 plus c. So what's that? 12 on 2 equals neg half plus c. C equals 13. 13 on 2. So my equation of the line is y equals half x plus 13 on 2. And here I can see why it's nicer to put it in the different form. I can just multiply everything by 2. 2y equals x plus 13, and then of course that's going to be neg x plus 2y minus 13 equals 0 for the form that they're asking for. So here I can see a reason, I guess, to multiply everything by 2, although if it didn't specifically ask me, I would not waste time. That would be my final answer, and that'd be 100% correct. So just when you're looking at the answers in your book, if they do give a different form, it doesn't necessarily mean that you're wrong. How you could check that, if the back of the book said this and you wanted to check it quickly, you could just do a quick solve on CAS, comma y, and then it will put it in y equals mx plus c form. So if you're using the y equals mx plus c equation, as I have for these, that's a quick way to check. Okay, next, I think this is, maybe not, 2 more to go, sorry. Okay. So calculate to 1 decimal place the angle made with the positive direction of the x-axis by the line that passes through the points, blah, 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 blah. Okay, so the angle made with the positive direction of the x-axis. So if we think about what that means, there's some line, and this is the angle in here. And the formula we have is tan theta equals the gradient. So this is actually really quite easy, but people don't know what to do. It also says correct to 1 decimal place, so it means we are going to be using CAS, and we're going to be getting a decimal answer there. Unless it specifically asks you for a decimal, you always use exact values, as has been the case since year 10. So more important than ever now, though, to be careful of that. So let's find the gradient. What I would do if I were you, label x1, y1, x2, y2, because you can, like, it just sometimes people stuff up which one's x1 and y1 and x2 and y2, and then of course it will be wrong. So if you do that, you're not going to make a silly mistake. So the gradient is 1 minus -2, so y2 minus y1 over x2 minus x1, 3 over 7. So our gradient there is 3/7, and now we can just put it into this formula. So tan theta equals 3/7, and then to solve for theta, it's the inverse. And you just do this on your cat, so I'm not going to show you a picture of it. I think really you have done that probably since year 9. So this is in trig, and then it's just that inverse. And you want to make sure that your CAS is in degree mode for this one. We often use radians for year 12 methods, but for this they're asking in degrees. To one decimal place, yeah, they'll be asking, it'll be for degrees there. And secondly, we're using decimals, so you can put it into decimal mode there. And I got for that theta equals 23.19859. And look, just a word about rounding. They ask for 1 decimal place, so that's quite easy because then it's just 23.2 degrees, and that's your answer. But I just wanted to point out to you, if it was 2 decimal places, some people are going to lose a mark here because some people are going to write, they're going to say, well, here's an 8 here, so that rounds up, and people are going to go, oh yeah, well that's 23.2 degrees, and you're going to lose a mark for that. It's a 0 here, and they want 2 decimal places, so you need to give them 2 decimal places. So because there's an 8 after our 2 decimal places, we're plussing 1 over here, and 9 plus 1 is 10. You need that 0 there, 23.20. So just where it asks for 2 decimal places, give them 2 decimal places. Even if you think, well, that's a 0, who cares about that? You need to give the correct number of decimal places. Okay, that's that. And then determine the equation of the line that passes through the point 52 at an angle of 45 degrees. So just pop that here so we've got a little bit more room. Now, this is the angle of 45 degrees. So when we've got an equation of the line y equals mx plus c, the gradient, well, we can get from that angle, and that's tan theta equals m, and tan theta, tan 45 degrees equals m. And look, this is a really common one, tan 45a, it's in the table of exact values, so you should know it. But I mean, even if you don't know the table of exact values so well, tan 45 is 1, and that comes up all the time, so you really want to know that. So the gradient is 1 here. So far we've got y equals 1x plus c. Of course, the 1 is not necessary there, but I write it just to point out that we have solved the gradient, and now we just need to find c. Passes through the point 52. So let's just pop the point in. So 2 is y. So 2 equals 5 plus c. Notice that I always use brackets. It's really not a good idea to use multiplication sign in more complex calculations. It ends up looking like an X, and people end up making stupid mistakes. So use brackets, they're nice. So y equals x minus 3 would be our final answer. All right, and lucky last, I think. Here's a word about midpoint and distance between 2 points. I'm not going to go into detail of these. I've actually made another video which I will attempt to put a link, like one of those little card things or whatever, at this point in the video, so you can click on that and go to my explanation of how in particular the distance formula works. That's really important to understand. Midpoint, it's just the average of the 2 x values and the 2 y values. It's pretty straightforward. The distance formula, people stuff this up to no ends with the negatives and positives, and you won't if you just understand it's Pythagoras. So please do check out that video. I might put it in the comments as well if I can work out how to do that. All right, so given the points -3, 5, and 4, -6, calculate the midpoint. Well, let's do that first. Midpoint is easy. And look, if you didn't master that in year 10, now's the time. We've done it in year 10, we've done it in year 11. You add together the two x values, -3 plus 4, you divide it by 2. It's the average of the x values. And then, well, guess what? It's the same for this. So the y5 plus -6 over 2, the average of the y values. -3 plus 4 is 1, and 5 plus -6 is -1. And notice I don't put the negative here. That's really babyish. You know, it's the whole value is negative. So that's our midpoint. Easy. The distance between the 2 points. So I'm just going to do it. I'm not doing it for the understanding way, as in you can look at my other video for that. You might like to fast forward to the distance formula part because it gives a really good explanation of how that is directly Pythagoras, and you will never forget it then. I'm just going to use the formula. So distance equals y2 minus y1 squared plus x2 minus x1 squared. So what this really is c squared, equals a squared plus b squared. And I did say I'm not going to be doing an explanation of that here, so I will not do an explanation of that here. So that's why we root both sides here. So let's sub the values in, -3, 5, or -6. And this is also important that you don't stuff up which one's x1 and y1. So you don't want this to be y2, for example. You must make sure you put them in the right spots, x2 and y2. And if you do that, you save yourself that trouble. y2 is -6 minus 5 squared plus x2 is 4 minus -3. Be careful, you've got double negative there. -11 squared is 121. 4, 5, 6, 7 squared is 49. So it's at 170. And I don't think we can simplify that. No, we cannot. So it's just root 170 units. And notice that I write units on the end. If we were looking at an area, then it would be units squared. We're looking at a distance. It's just units. So that will be our distance between those 2 points. So that covers exercise 1.2, the linear functions. So now you should be able to go ahead and do the questions. If you are from my class, I will highlight that for you. And yeah, that's all.